Hello students and welcome to this college algebra lesson under the ODEL program. I'm Dumisani, your lecturer for this course. In today's video, we'll be learning about functions, what they are, how to represent them, and why they are fundamental concepts in algebra. So by the end of this lesson, you should be able to identify, evaluate, and interpolate functions in various forms. Make sure you have notebooks ready and feel free to pause and rewind the video as needed. So let's get started. So as I've mentioned, today we are looking at the functions. So our focus today is on functions. So if we look at the learning objectives that we have here with me, at the end of the lesson, we should be able to understand what is a function, use proper notation of functions, identify a domain and range of a function, represent functions using tables, graphs, and equations. So here are the key terms for this class. So the key terms are functions, domain, range, function notation, independent variable, and the dependent variable. So let's start by defining what is a function. So a function maps each element from a set of inputs, which we call domain, to exactly one element in a set of outputs. So the keywords here are inputs. So the keywords are inputs and output. So we have a set that contains inputs and we have another set that contains outputs. So we are basically mapping elements from one set to another. For example, if we have a function f of x equal to x plus 3, we can map values from one set that contains values 1, 2, 3 to another set that contains values 4, 5, and 6. So let me explain that using the whiteboard. And before we proceed to the example, let me explain the notation that has been described here. So this notation. So let me explain this notation here. So I would like to explain first this notation that is here before we look at the example. So when we are looking at functions, so let's not forget that we are looking at functions. We say that f is our function that is mapping. So it's a function such that it is mapping values from set X. So we have elements in set X being mapped onto another set Y. So it means we have a set that contains inputs a set that contains inputs, and another set that contains outputs. So a set that contains inputs and a set that contains outputs. And the inputs in this case are the ones that we are calling domain. And the outputs is the one that we are calling range. So keep these terms somewhere. We're going to use them later. So we can represent a function as an equation. We can represent a function as an equation. So I'll be using this example to help us understand the concepts as we go along. For example, we can represent a function as an equation. In this case, if we are representing a function as equation, it is going to be written as follows. So we write this as f of x, which is equal to x plus 3. So it is a function which is read as f of x equal to x plus 3. So in this case, we have represented a function as an equation. So the x is your input. The x is your input. The f is your function. And the f of x, the f of x is the one that we call the output. And in this case, it's the range. And the input is the domain. So there are three things here that we should take note. We have the function, which is being represented using f. Then we have the x, which is the input to the function. And we have f of x, which is the output. And in this case, we have represented a function as an equation. So this is the first. So we can say this is number 1. So this is number 1, where we have represented a function as an equation. In another scenario, we can use arrow diagrams to represent a function. So using arrow diagrams. So by using arrow diagrams, so I'll use the same example that we had last time. So by using arrow diagrams, I'll illustrate an arrow diagram for the case where we have a function f of x equal to x plus 3. So the arrow diagram for this scenario can be represented as follows. So we have input 1, input 2, input 3. So we have 3 inputs that are being substituted into our function. So in this case, we substitute 1. We take 1. In this case, we take 1 and put it where there's x here. So if we put 1 where there's x, it means here where there's x, we are going to have 1 added to 3. So it will be 1 added to 3. So 1 added to 3, it will give us 4. So in this case, our output will be 4. Okay, so let's map that one. So in this case, we are going to have, let me use my black color. So we're going to have 1 mapped to 4. So in this case, we are representing a function using arrow diagrams. So 2 in this case will be mapped to 5, because 2 plus 3, it will give us 5. So 2 mapped to 5. Then 3. So try to guess what would be the output. You can close it. So here the output will be 6, because it's 3 plus 3. So in this case, we have 2 things. We have the input and we have the output. So we have represented a function using arrow diagrams, using an arrow diagram. So this is the input and this is the output. However, as we move along, I want you to always remember that in the definition of functions, it was mentioned that just a second. Yeah, there you go. So in the definition, remember we said that we are mapping elements from one set to another. Okay, so I've already explained that. However, I want you to take note of the word exactly one element. It has to be exactly one element in the output. So the set containing outputs, in that case, we have to have exactly one output corresponding to an input. So we have to have exactly one element in the output that corresponds to a particular element in the input. So please take note of that. All right, so let's proceed. So we can also represent a function using tables. So using tables, we can represent functions. So we can basically say as tables. Oh yes, let's just say table. Okay, so representation of a function as a table. So using our previous example, for function. So we have a function f of x, which is equal to x plus 3. So I'm using the same example that we had for a function. So representing a function as a table, we are going to have two columns. The first column that will contain x, and another column that contains f of x. So the first column, we can put in inputs. So for example, let's try other numbers. So let's put 1. Let's put 0. Let's put 1. Let's put 2. Let's also just add another one, 3. So we have chosen those ones. We would have chosen any other inputs, but in this case, I've chosen 0, 1, 2, 3 as our inputs. So we are going to take this 0 and substitute where there's x. Where there's x, then we have 0 plus 3, we get 3. Then we get 1 where there's x, then 1 plus 3, we get 4. So that's the output when x is 1. When x is 2, the output is 5. When x is 3, the output is 6. So in this case, we have a table that represents our function. So this is a representation of a function using a table. So we can also represent a function as using a graph. So number 4, using a graph. So using a graph, in our case, so I'll still use the same. We are basically plotting. Points x, comma f of x. So we are plotting x, comma f of x. So it means if we go on the Cartesian plane, we're going to have y-axis, which is the f of x in this case. All right, so we have our f of x, and this is our x. So if you look at the function that we had, when x is 0, y is 3. So we can just put some numbers. So let's put 1, let's put 2, let's put 3, let's put 4. And here let's put 1, let's put 2, let's put 3, 4, 5. So from the previous scenarios that we had, from the previous scenario where we're looking at the values presented in the table format, 0 was paired with 3, 1 was paired with 4, 2 was paired with 5, 3 was paired with 6. So in this case, we can basically just indicate the points on the graph. So we have 0 paired with 3. So 0 paired with 3 is this point somewhere here. Yeah, I think I should have drawn it a little bit down. So what we can do is try to do this. Just shift it down. We can do something like that. Okay. Move this down. Yeah. See, let's see if yeah. So I think we can move this down here. And this is the x-axis. This is 1 and 2. This is 4. And this is 3. Yeah, there we go. So it means we'll have a point. We'll have a point somewhere here. So 0, when x is 0, y is f of x is 3. So our f of x is here. We bring it down. You try to bring it down. Okay, that's fine. I think be able to see. All right, so we have our point, first point, 0,3. Another point, we have it when x is 4, when x is, not x when x is 4, but when x is 1, y is 4. So we'll have something there. And when x is 2, y is 5. So I'll just add 5. 5. So it's not to scale, but basically you get the idea. So we have another point. When x is 2, y is 5. So we join those points. So we join the points. We have our straight line. So we can extend it. It's fine. We can extend it. Or let me try to use red. Let me try to use red. And let me pick this that. Yeah. So we'll have it some that. So we basically a straight line. So this is straight line represents f of x equal to x plus 3. So this is a representation of a function as a graph. So at this moment, I'll ask you to represent. Okay, so activity. So let's say we are given f of x. Yeah, let's say we're given f of x which is equal to x squared. So in this case, we have written a function as an equation. So what I want you to do is to represent this function using arrow diagram. So represent this function using arrow diagram. Use table. Do the same, represent using graph. And something just a bonus one. Represent using a set of ordered pairs. A set of ordered pairs. So you can pause the video. You can pause the video and try to do this activity and come back to see the answers. So I will show you the answers after you are back. All right, so welcome back. So let's do the activity. I hope you have your answers with you. So from the activity, remember we are given f of x, which is equal to x squared. So this is our function. So that's our function. So let's represent this function. So the first part, we're asked to represent using arrow diagram. So it depends the values, it will depend on the values you have chosen, but it will be similar as long as you follow the rules. So using an arrow diagram, so I can draw this shape just to help me carry the input. So I can have input -1, input as 0, input as 1, input as 2. So here the output would be as follows. If we take -1 and substitute where there's x, we're going to get 1. If we substitute 0 where there's x, we're going to get 0. If we substitute 1 where there's x, we're going to get 1. If we substitute 2 where there's x, we're going to get 4. So in this case, we are mapping -1, 1, 0, 0, 1, 1, 2, so 2, 4. So in this case, we don't have to write this 1. Because remember, we are looking at mapping a value from one set to another set. So in a set, repetitions are irrelevant. So repetitions are irrelevant. So having one single number is fine. You don't have to repeat the numbers. So if we are to label this, this is your input. This is output. So you have your input and your output. So the input is the x, the output is the f of x. Right, so we are done with first part. The other part is representing a function using a table. So this is arrow diagram. Arrow diagram. So representing a function is a table. Using a table, representing a function using a table. So in this case, with this example we're going to have x and f of x. Okay, so 2 columns. Okay. So it will depend on the values that you select. So for example, we select -2, we select the -1, 0, 1, and 2. So -2, if substituted into our function, don't forget this is our function, f of x equal to x squared. For f of x, we put -2 where there's where there's x, we get 4. -1 will give us 1, 0 will give us 0, 1 will give us 1, then 2 will give us 4. So this is a representation of a function using a table. I hope that's clear. So it depends on the values. So your table will depend on the values you chose for x. So as long as the values that we chose have the correct output, you're good to go. So let's go to the next one, presenting a function using graphs. So I'll still use the same values that I have here in the table. So as graphs, using a graph. So using a graph, we'll need the x-axis. So that's our x-axis, then the y-axis. And the y-axis, that's our f of x. That's our y-axis. Okay. So from the values that we have seen so far, we know that we have a point 0, 0. When x is 0, y is 0. So that's the origin. But in our set of inputs, we have 0, we have 1, we have 2. Okay, so we can stop there, it's fine, or we can just add another value. And here we have -1, we have -2, we have, I think we have a -2. So it's fine, we just add another one, -3. For the output, we only have positive values. So we have 1. We can go to, let's just use C1, 2, 3. So this is 3. Forgive me my handwriting. So here this is 3, 4. So from the previous table, let me try to use a different color. Let's use this one. So from the table, we have 0, 0, which is the origin. So I'm using this table. So 0, 0, that's the point. And another point is when x is 1, y is 1. So when x is 1, y is 1. When x is -1, y is 1. So that's the point. So when x is -2, y is 4. So let's do this. So let me bring back my point here. Then the other one is 4. So it's somewhere here. And the other one, when x is 2, it is 4 on this side. So I'll try to draw a smooth curve to represent our function. So that's our smooth curve. This side, that's our curve. So this is a curve representing y, which is f of x equal to x squared. So in this case, we have represented a function as a graph. So the last one was a set of ordered pairs. So as a set of ordered pairs, we can represent it as follows. So set, so let me use a different color so that you're able to see. So set of ordered pairs, a set of ordered pairs. So as a set of ordered pairs, so I'll use the same values. Okay, for simplicity, I'll still use the same values. So in this case, we can represent a function as a set. So you know what a set is. So as a set, let's use our blue. Okay, so we have a set. So if you look at the table, -2 is mapped to 4. So we can have a pair, so -2, 4, comma, we go to -1. So -1 is paired with 1, then 0 paired with 0, 1 paired 1. So these are the pairs. Then the 2 paired 4. This bracket. So here we have represented a function as a set of ordered pairs. So from here, I'll also, from this example, also explain what it meant by we have to have exactly one output. So it is not possible to have -2, 4 and also have -2, 3. We cannot have this. This is not possible. This is not possible. It's not possible. Because for a function to exist, it has to have a unique output. It has to be a unique output. So it's not possible to have the same input giving us different outputs for the same function. Okay, it's not possible to have both for the same function. So I hope I've brought that point again that is found in the definition. So I'll try to give you some practice questions in the document that I've sent. Please try the questions, and if you have any other questions, please send them on Moodle or any other platforms that are allowed by the university. All right, so let's proceed. Let's finish by defining in detail what is a domain and what is range, and we should also look at some examples. So let's go back to our file. So we have looked at all this. We have looked at all this. So this is the handout that you'll use later for study. So we have looked at function as an equation and the like. So now let's look at the domain range in detail. So a domain is a function. Sorry, not a function, but a domain of a function is the complete set of possible inputs. So we are looking at a set that contains inputs, and we usually present a domain, the values of a domain, using X. And the domain should contains only values that will assure or that will make sure a function is always defined. So values that are always giving us a function that is defined. And a range. So looking at the next one, so you can check through all this. So a range is a set of all possible output values. And we represent this using f of x. Example, if we are given a function f of x equal to x squared, in this case, the domain is the set of all real numbers. So in this case, there are no restrictions for the input. So you're looking at all the values on the rule line. For the range, we have from 0 to infinity. So in this case, we are only restricted to positive values, because remember, f of x equal to x squared, if you remember the graph, it is only defined above the x-axis, so it gives us positive values for the f of x. So they are all positive. So starting from the origin, towards infinity. If we have f of x equal to 1 over x minus 2, the domain is defined for all values except x equal to 2. Except x equal to 2. So it is not defined for x equal to 2 because it gives us division by 0. Because if we take 2 and substitute where there's x here, if we substitute 2 where there's x, we are going to get 1 divided by 0. So we do not want to divide by 0. So in that case, the domain is, for this scenario, we have all values except x equal to 2. So for the range, we are basically looking at all real values except that when x is equal to 2. So in this case, we are trying to communicate that f of x is never equal to 0. Because if you look at the scenario that we have, there's no way we are going to have x equal to 0. In this last example, we have f of x equal to square root of x minus 3. So for a square root, the numbers that are inside should always be positive. So for it to work in this case, for this to work, x must be greater than or equal to 3. So if you put, where there's x, if you put 4, it's going to give you 3. If you put 10, it's going to give you 7. But if you put 0, it's going to give you negative 3. If you put negative 1, it's going to give you negative 4. So we do not want to have the square root of a negative. So in that case, the domain will be defined all values above or equal to 3. The range, we are only also focusing in this case values from 0 to infinity. So we have some practice questions here. Identify the function rule, domain, and range for these scenarios. You do the table and you do the graphs. So I have already shown you the graph for this one. You can try out the graph of x, f of x equal to x to the power 3. So you can try that for practice. So in summary, we can think of a function as a rule that relates inputs to exactly one output. The domain tells us which x values we can use, so that's the domain. The range tells us what values of f of x can take. The values f of x can take. And another thing that we have learned is that we can represent functions visually using graphs, numerically using tables, algebraically using equations. So in our next lesson, we are going to look at the composite and inverse function. Thank you for watching. See you next time.